Alright, good day everyone. So welcome back to my YouTube channel, and this is Kasaligan Vlogs. Today we'll be talking about measures of central tendency, and this is part of statistics. And this subject is all about mathematics in the modern world. Alright, so ladies and gentlemen, let's start with the measure of central tendency definition. A measure of central tendency is any single value that is used to identify the center of the data or typical value. It is often referred to as the average. There are four measures of central tendency, namely the mean, median, mode, and the mid-range. So let's start with the mean. So arithmetic mean or the mean, the most common average, and sometimes simply referred to as the mean. So the sum of all values of the observations divided by the number of observations. The symbol x bar is used to represent the mean of the sample, and the symbol mu is used to denote the mean of the population. The sample mean used to estimate the population mean. So here are the properties of the mean. The first is the sum of the deviations of all measurements in a set from the mean is 0. So we'll be talking about that one later. We're talking about what we mean by property number 1. And number 2, it can be calculated for any set of numerical data, so it always exists. And number 3, a set of numerical data has one and only one mean, and it lends itself to higher statistical treatment. It is most reliable since it takes into account every item in the set of data. And number 6, it is greatly affected by an outlier or extreme or deviant value. So meaning to say it can be easily affected when there is an outlier, so the mean would easily affected with this one. Or they have extreme values. For example, 111 and it becomes 100, so the extreme value is 100. 1 2 3 4 5 6 7 8 9 10, and there is 100 here, so there is an extreme value. So number 7, it's used only if the data are interval or ratio level and when normally distributed. So take note of this measurements. It should be ratio or interval when normally distributed. So rounding rule for the mean, we have the mean should be rounded to one more decimal place than occurs in the raw data. For example, if the raw data are given in the whole numbers, the mean should be rounded to the nearest tenth. If the data are given in a tens, the mean should be rounded to the nearest hundredth, and so on. So take note of this rounding rule for the mean. So it will be used as we're going to have our computation with the mean. So mean for ungrouped data. So we have here, so the first part is the mean for sample mean, and the second one is the population mean. So the symbol, it differs only for the symbol. This is a symbol for sample, and this is a symbol for population mean. So we're x bar simply means at x bar, and the value of any particular observations or measurement, that's the value for x, and summation of all of x, and the number of total values in a sample. The same way the population mean, it is replaced by the mu, and still we have x is the value of any particular observations or measurements, and the summation of all x and the total number of values in the population. So take note of the formula. We have to going to add all the data, then divide it by the number of data. So this is for ungrouped. So let's start with problem number 1. The data represent the number of days per year, for example, of individuals selected from the 9 different countries, and find the mean. So we have here 20, 26, 40, 36, 23, 42, 35, and 24, 30. So we are just going to add. Okay, so we have here the solution. So in finding the mean, we have x bar. Okay, x bar is equal to the summation of x over n. Okay, so the summation of x over n, so we have here, we're just going to add, we have 20 plus 26 plus 40 plus 36 plus 23 plus 42 plus 35 plus 24 and plus 30. I guess this is 30. Okay, 30. And divided by the number of observations. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So divided by 9. So the mean here is, so we have here the total of this one is, if we're going to total this one, you have 276 divided by 9. So we have 30.7 days. Okay, so 30.7 days. So we can conclude that hence the mean of the number of days off is 30.7 days. Okay, so we have here the mean is, hence the mean of the number of days off is 30.7. So that's it, and how to find the mean of the given. Okay, so let's proceed with the number 2 problem. The data show the number of patients in a sample of 6 hospitals who acquired an infection while hospitalized. Find the mean. So we have here 110, 76, 29, 38, 105, and 31. So same with in solution. So we have here x bar is equal to summation of x over the n. So we have here our x is 100, our data are 100, 76 plus 29 plus 38 plus 105, I guess it's 105 plus 31. So we have to sum up this one divided by the number of observations, which is 1, 2, 3, 4, 5, 6. So we have here the mean is 389 divided by 6. So we have 64.8. So we could say that the mean of the number of hospitals infections for the 6 hospitals is 64.8. Okay, that's it for solution number 2. So the mean of the number of hospitals infections for the 6 hospitals is 64.8. So try this at home. So the number of employees at 5 different gift shops are 4, 8, 10, 12, and 6. Find the mean number of employees for the 5 stores. If it is being identified as population mean, so make use of the population formula. But if that is, for example, this one, we have sample, it is being identified as sample, so just make use of the formula for sample mean. And we have number 3, compute the mean score of the following data. So just get the mean. Okay, so let's proceed with the next measure of central tendency, which is next is the weighted mean rather. So let's have first the weighted mean. So applicable to options of different weights, useful when various classes or groups contribute differently to the total. It is found by multiplying each value by its corresponding weight and dividing by the sum of weights. So we have here the symbol is WM, WM then bar. So we have here the bar here should be placed here, bar is equal to summation of f of x, where f is the frequency of each weight and x is corresponding weights. Okay, frequency of each weight and corresponding weights over the summation of frequency. So take note of this, formula. So problem number 1, the instructor determines the student's weighted mean from quizzes, tests, and project. Each test uh, counts as 4 quizzes and the project counts as 8 quizzes. Larry has quiz scores of 70 and 55 and his test scores are 90, 72, and 68. His project score is 85. Find Larry's weighted mean for the course. So of course we have here the formula weighted mean equals summation of f of x over summation of f. So we have here so let's determine. So what is the weight of 70 here? First is 70. So Larry has quiz score 70. So 1 times 70. Then you're going to add 1 is the frequency and 70 is the weight. And plus we have 1 times 55. Then plus the next is we have his test scores are 90, 72, and 68. And test scores, each test counts as 4 quizzes. So therefore we have 4 times 90, then plus 4 times 72 plus 4 times 68. After which we have his project score is 85. So 8 and this is 8 quizzes. Counts as 8 quizzes. So plus 8 times 85. So sum of this one divided by the number of frequencies. So just going to add 1, 1, 4, 4, 4, and 8. We have 22. So if we're going to calculate this one, the result of this one is 1725. Okay, multiply, and then add, divided by 22. So therefore, the weighted mean is approximately 78.4. So it's the answer. Approximately, we have 78.4 for problem number 1. Let's proceed with problem number 2. A student received an A in English composition and C in Introduction to Psychology, 3 credits, and B is Biology, 4 credits, and D is Physical Education. Assuming A 4 grade point, B 3 grade points, C 2 grade points, and D 1 grade point, and F is 0 grade point. Find the student's point average. So we have here, so if we're going to take down of this part, so you have here the course. Okay, we are going to list down the course. We have English composition, and the credits is, okay, the credits, we have 3, and the grade, okay, the grade, which is assuming that in class A, which is A is 4 points. So we have here, for A, we have 4 points. Next, we have Introduction to Psychology. We have 3 credits, and A and B is 3 points. Okay. Introduction to Psychology. Next, we have Biology. So biology, we have 4 credits, and we have the biology is 2 to C, which is 2 point. And for we have physical education, we have PE, we have 2 credits, and we have, for letter D, we have 1 point. And F is 0 grade point. So we don't have F here. So we have here the weighted mean, just multiply. This is our frequency and this is our X, because the frequency is the credits and grade is the weight of the grades. So summation of f of x over summation of f. So multiply first summation of frequency. We have 3 times we have 4. 3 times 4. Okay, 3 times 4 plus 3 times 3. Okay, so we have summation of frequency and the grade. Okay, frequency 3 times 3 plus 4 times 2 and plus 2 times 1. This equal over, you have 3, 3, 4, and 12. Okay, divided by 12. So we have 12 plus 6 plus 8 plus 2 over 12. That is equal to 32 over 12. So equal to, we have 2.7. Okay, so therefore we could say that the grade point is, this is the grade point. Okay, the grade point. So the grade point average is 2.7 in this problem number 2. So thank you. So next we have, try this at home. Find Larry's weight mean in problem number 1 if the test scores counts as 2 quiz scores and project counts as 6 quiz scores. At the College of Engineering, we have here assistant professors, and their monthly salaries, and we have to find for the weighted mean salary. And grades in 4 courses, find the weighted mean. So here are the grades and the unit frequency. So just get the weighted mean. Okay, so let's proceed now with the next measure of central tendency, and it's the second one, which is the median. The median is the midpoint of the data array, and a point is scaled such that above or below it lie 50% of the class, denoted as MD, or the median. So properties of the median is unique. There is only one median for a set of data. Take note of the property. The median is found by arranging the set of data from lowest or highest and getting the value of the middle observation. Just get the middle observation of the data given. And median is not affected by extreme value, small or large values, because we're going to count the number of data, and we are going to get the center part, or the middle part, or the middle point. Median can be computed for an open-ended frequency distribution, and median can be applied for ordinal, interval, and ratio data. So it's all about properties of the median. So median rules for ungrouped data, we have rules. First, if n is odd, the median is the middle rank. If n is even, the median is the average of two middle rank values, or the middle point. So first, there are steps. Arrange data in ascending or descending order, and identify the median in the data set, or select the middle point. So there are 2 steps only, so we have to remember this. So problem number 1, the number of rooms in the 7 hotels in downtown Pittsburgh is 713, 300, 618, 595, 311, 401, and 292. So find the median. So the first step is we're going to arrange the data in descending or ascending order. So let's start with ascending order. So you have 292. Next we have 300. Okay. Next is 311. Next is 401. Next is 595. Okay. Next is 618. Next is 713. Okay, so that I tallied already all the data provided. So second step is we're going to get the middle part. So 1, 2, 3, and this is the middle part. So therefore, this is the median, which is 401. So the median of the number of rooms in 7 hotels in downtown, which is the median is 401. Okay, so let's proceed with problem number 2. Find the median for the daily vehicle pass charge for 5 U.S. national parks. The costs are $25, $15, $15, $20, and $15. So the first step is we're going to write the data in ascending or descending order. So let's have ascending order. So $15. Okay, next is $15. There are three $15 here. Okay, next is $20 and $25. So listed already all the data. So just locate the middle part. So 1, 2, 3, 4, 5. So therefore this is the middle part. So this is the median cost is $15. So this is unimodal. Okay. So find the median of the daily vehicle. So therefore the median cost is $15. Problem number 3, the number of tornadoes that have occurred in the United States over 8-year period follows. Find the median. So first step is we're going to write the data in ascending or descending order. So let's have ascending order. 656. Next we have 684. Next we have 702. Next we have 764. Next we have 856. Next is 1132. Next is 1133. Next is 1303. Okay, so this is arranged already in ascending order. So just count the number of data: 1, 2, 3, 4, 5, 6, 7, 8. Since this is an even number, so just locate the center part. So the center part 1, 2, 3, 4 and 1, 2, 3, 4. So the center part is here. So just get the MD, the midpoint. The midpoint is just dividing 764 plus 856 divided by 2. We have 1620 divided by 2. So the midpoint is 810. So we could say that the median of tornadoes is 810. Okay, the median of tornadoes is 810 of this problem number 3. So problem number 4, 6 customer purchased these numbers of magazines: 1, 7, 3, 2, 3, 4. Find the median. So in finding the median again, so you're going to arrange the data in ascending order or descending. So let's have ascending: 1, 3, 1, 2, 3, 3, and 4, and 7. So how many data we have? So 1, 2, 3, 4, 5, 6. So it's even. So take the middle part. So add and divide by 2. So MD is equal to 3 plus 3 divided by 2. We have 6 over 2. That is equal to 3. So this is the median, where the median purchase magazine for a 6 customers. So this is the median for the numbers of magazines. Okay, so these are 6 customer purchases numbers of magazines. So the median is 3. So try this at home. Find the median of the following set of scores, and we have 3 items to be solved. Next, we have the mode. Okay, mode is the observed value that occurs most frequently. It does not always exist, and if it does, it may be unique. A data is said to be unimodal if there is only one mode, and bimodal if there are 2 modes, and if a data set has more than 2 values, that occur with the same greatest frequency, each value is used as the mode. And the dataset is said to be multimodal when it is more than 2. These There are some cases when the dataset values have the same number of frequency. When these occur, the data is said to be no mode. And it is not affected by extreme values. It can be used for qualitative or qualitative as well as quantitative data. And it's denoted by MO. Okay, so we have here the mode denotation. So properties of the mode. The mode is found by locating the most frequently occurring value, and the mode is the easiest average to compute. And there can be more than one mode or even no mode in a given data set. For example, they have no mode if the same frequency. Mode is not affected by extreme small or large value, of course, because we're just going to locate the most frequently occurring value. And mode can be applied for nominal, ordinal, interval, and ratio data. It could be applied all of the measures or measurements. Okay. So problem number 1, find the mode of the signing bonuses of 8 NFL players for a specific year. The bonuses in millions of dollars are 18, 14, 34, 10, 11.3, 10, 12.4, and 10. So first is we're going to write here our x and the frequency, which is 1 only. So next is 14, the frequency is 1, and 34.5, the frequency is 1, and 10, the frequency is 1, 2, and 3, and we have 11.3, only 1, and 12.4, only 1. So therefore we could say that the mode is 3. The mode is 10 rather. The mode is 10. So it is very helpful if you're going to make this in this kind of arrangement. So we are going to get the frequency so that we could be easily to locate what is the mode. The mode here is 10. 10 millions. Okay. Okay. The mode is 10 millions of the dollars of the bonuses of the 8 NFL players for a specific year. So we are going to make an interpretation here. So therefore we could say that the mode is 10 millions out of the bonuses of the 8 NFL players for a specific year. So that's how to interpret. Next is problem number 2. Find the mode for the number of branches that 6 banks have: 41, 401, 344, 209, 201, 227, and 353. So first is we're going to jot down. Okay. So we are going to jot down the mode of the number of branches. So we have 401 and 344. This is our x and this is the frequency. 1, 1, 209, this is 1, and 201, this is 1, and 227, this is 1, and 353, this is 1. So if we're going to look at here for the 6 banks, so the same frequency, so therefore we could say that there is no mode. Okay, no mode for the 6 number of branches that 6 banks have. Okay, so since the same frequency. Next, problem number 3. The data show the number of licensed nuclear reactors in the United States for a recent 15-year period. Find the mode. So first is we're going to jot down the number of frequency. Of course, we have the x and the frequency. Let's start with 104. 1, 2, 3, 4, and 5. And 107. So you have 1. 109, we have 1, 2, 3, 4, 4, and 5. Next, we have 111, so we have 2. Next is 112. Okay, 112, this is x and f. 112 is 1. Next is 110, which is 1. So we could say that the highest frequency is 105 and 104. So the modes are 104 and 109 and said to be bimodals. So this is 104 and 109 are the modes, and this is bimodal. Okay, so this is bimodal. The last problem is no mode, and this one is bimodal. Next is try this. Find the mode of the data in the following lists. So we have here, you're going to identify the mode, and what kind of mode is this? Is a mode multimodal, unimodal, or bimodal. So try this one at home. So thank you for listening for the mode. Next is the mid-range. The mid-range is a rough estimate of the middle. It is found by adding the lowest and highest values in the dataset and dividing by 2. It is a very rough estimate of the average and can be affected by one's extremely high or low value. So the mid-range is defined as a sum of lowest and highest value in the dataset divided by 2, and the MR is used to denote for the mid-range. MR is lowest plus highest value divided by 2. So the properties of the mid-range is easy to compute. The mid-range gives the midpoint, and the mid-range is unique, and the mid-range is affected by extreme small or large values, because it can be when there is extreme or small values, there could be no exact, or we could say that this is not typical for the mid-range, or the mid-range for that particular data. So mid-range can be applied for interval and ratio data. So let's start problem number 1. In the last 2 winter seasons, the city of Brownsville, Minnesota, reported its numbers of water line breaks per month. Find the mid-range. So the mid-range is just going to have the highest and the lowest value. So let's have the mid-range. So we have, okay, so what is the highest value? The lowest value is 1, and the highest value is 8 divided by 2, which is 4.5. Because it's 9 divided by 2, we have 4.5. So therefore, this is the mid-range of the data. 4.5. So highest, lowest plus highest divided by 2. In problem number 2, find the mid-range of the ages of 9 middle management employees of a certain company. The ages are 53 and so on. So first is we're going to find the MR. So the MR is equal to the highest or the lowest. So 53, 45, 59, 48, 54, 46, 51, 58, and 55. So the lowest value is 45. And we have here the highest value is, okay, the highest value is 59. So 59 divided by 2, we have 104 divided by 2, we have 52. So the mid-range is 52, and this is the mid-range. So that's all about problem number 2. And try this. So find the mid-range of the following data temperatures which were recorded in the 3-hour intervals, and find the mid-range of the following daily temperatures which were recorded at 3 hours interval. So thank you so much everyone for listening for these videos. I hope you will subscribe, and please click notification bell for you to be notified for the next videos that I have. So thank you so much, and please subscribe, and thank you for listening. I hope you will try this at home, and please comment your answer if you have your answers there. So thank you, and once again, God bless.